Okay, this headline made me so mad that I went and found some software that I could download in order to make a video to explain why not only is what this guy was saying not possible, but he knew that it was not possible. I've seen a lot of videos on protein synthesis in my life, which is basically what we're going to cover really quick. They vary in complexity, but there's really not a reason to make it super complex. The fundamentals are really easy to understand, and I think you'll understand at the end of this. Or so if someone you know is anxious about the vaccine, feel free to share with them too. Hold on, bear with me, new software I'm learning. So the reason I say this guy had to have known that wasn't possible is one of the first things you learn in biology, which, having gone to pharmacy school and being pre-pharmacy, he would have taken lots of biology classes, is what is referred to as the central dogma of biology. Basically, that all living things have DNA. All living things are made of protein. DNA gets turned into RNA. Off to a great start. And that gets turned into protein. All you are, essentially, is a bunch of proteins stuck together. Every living thing. What DNA is, and we hear our whole lives is kind of drilled into our heads, is that DNA is a blueprint for making life. That's great. What does that mean? It really just means that DNA is like a protein recipe book. Right? So, what is this mysterious molecule RNA that these vaccines are based off of, and how do they interact with my cells? Really, no big deal. Gonna explain it to you really quick. So, here's a cell, right? Nucleus of a cell. This is the outside of the cell. Chilling on the outside of the cell is the cell membrane. We're gonna give you the basic lay of the land here. This would be the nucleus. And outside of the nucleus is this jello-y stuff called the cytoplasm. Where can I? So all this blank space we'll just pretend is this jello-y cytoplasm substance. By now, you're probably familiar with the fact that your DNA lives inside the nucleus of your cells. I'm going to draw as I'm talking because I feel like it's fun when I watch videos that way. So I'm going to do it that way. And then another little guy we need to be familiar with is what's called the ribosome. I'm just going to make it like a little dot. These are protein factories. So the factories for making the proteins are in the cytoplasm, outside of the nucleus. But all of the instructions for making those proteins are inside the nucleus. Here's the thing. We don't want DNA to leave the nucleus because we don't want anything to happen to it. That's the blueprint for making everything. If something happens, it's called a mutation. Generally pretty bad news. So we want it to stay there. This is kind of like, pretend the internet doesn't exist, and imagine that your local library has this rare cookbook, first edition. They don't want you to take it out of the library, but you really want to make the recipe. Can't look it up online. So what would you do? You can't bring your kitchen to the library. You can't take the book out of the library. Well, they have copy machines. Make a copy. Guess what RNA is? That's it. That's all it is. It just makes a copy of the DNA. In this case, it's called messenger RNA because it's carrying the message. This is one time when scientists actually name something that makes sense, and I appreciate that. So, mRNA can travel in between the nucleus and the cytoplasm. So it can just go out to these protein factories and be like, hey, here's this protein recipe that I copied. Hey, ribosome, why don't you cook it up? And it cooks up whatever protein the recipe is for. Multiply that a bajillion times and you got a U, right? That's it. So the way that these viruses work, just some real quick virus anatomy. Let's make sure. Viruses have like a little container. They've got these little spiky things on the outside. Now, not all of them are going to be spiky, but the coronavirus, they refer to them as spike proteins, so I drew them spiky looking. So we're going to say this is a spike protein. All the scientists have done, in this case, is they've got that mRNA copy of that recipe for the spike protein. So they take this viral mRNA copy, they put it in your body, and your body's going to be like, oh, here's some mRNA, because RNA looks like RNA. You can't tell by looking at it unless you sequence it, which your body's not going to do. It's just going to, if there's mRNA there, the ribosome just goes ahead and cooks up whatever the recipe is for. So when it does that, though, when that mRNA gets to your ribosome and you end up making these little viral spiky proteins, your body's going to be like, wait a minute, we don't recognize these guys. Virus. Spikes. And be like, we're not punk rockers. What is this? And the immune system is going to get rid of them. Not only is the immune system going to get rid of them, but it's going to remember their shape so that if it comes into contact with them again, i.e. the actual coronavirus, it will destroy it before it has a chance to make you sick. Now, these proteins themselves, you don't have to worry because these proteins aren't actually the infectious part. The infectious part of the virus would be in the instructions. What viruses actually do is they would take over a cell and turn that cell into a virus-making factory until it literally explodes. Just the protein itself is not going to do that, right? Your body would need way more instructions. It would need all the rest of the instructions for making the virus to make it infectious. And we've only got one teeny tiny little part. So no can do. It's kind of like having chocolate chips for the chocolate chip cookies. It doesn't matter which way you cut it. If that's all you have, you don't have a cookie. Same kind of deal. So, does mRNA ever change DNA? No, it does not. That's the whole reason why it exists in the first place, right? Is because DNA can't have mutations are generally frowned upon in the living world. And, if you can avoid them by, keeping your DNA safe inside the nucleus and just copying them with this mRNA molecule, the better you are. And both of the vaccines function pretty much in the same way. The details are a little bit different. I don't think it's important. They're both focused on this little viral mRNA copy to just show your body what the virus spikes look like. Sometimes you can have vaccines that work by just exposing the protein to you. Sometimes they can take the virus and make the DNA non-functional, so just the outside shape of the virus gets introduced to your body so that your immune system can learn the shape that way. But for the moral of the story, it's not dangerous. That guy's full of it. It's not going to change your DNA. Take the vaccine. Any side effects of the vaccine, my dog just burped. I really hope that you heard it. Any side effects of the vaccine are way less severe than potential side effects of the coronavirus. So absolutely get it. And And anytime there's lots of uncertainty in the world, conspiracy theories abound. So just be patient with your fellow man, I think. But let's just try to get the word out and educate people. So if you have any questions, let me know. And I'm happy to explain things because that's how I do. Love you guys. Stay safe.